Okay, let's talk about Kubernetes. You've probably heard the name, and maybe it sounds a little intimidating. Well, don't worry, you're in exactly the right place. We're going to break it all down step by step with some super practical examples. The goal here is to take you from knowing basically nothing to understanding how to get an app up and running. So yeah, let's just dive right in.
So here's our game plan for today. First, we'll look at the core architecture, what I like to call the brains and the brawn. Then we're going to follow a single command from start to finish to see how it all clicks together. After that, we'll tackle networking, learn how to manage apps like a total pro, and then I'll point you to a few things you might want to learn next.
You know, every Kubernetes cluster really comes down to two main parts. You've got the part that thinks and makes all the big decisions, and you've got the part that does all the heavy lifting, the part that actually runs your apps. It's kind of like a central nervous system and all the muscles working together.
So what are these two parts really? Well, at its heart, a Kubernetes cluster is made of a control plane, that's our brain, and a bunch of worker nodes. And you guessed it, that's the brawn. Let's break down exactly what each of them is responsible for.
First up, the control plane. This is the absolute brain of the whole operation. It's got a few critical pieces. The API server is like the front door or the main receptionist. Every single command you send has to go through it. Then there's etd. Think of this as the cluster's memory, the single source of truth that stores the state of everything. The scheduler is like a matchmaker. Its whole job is to figure out which worker node is the best home for your app. And finally, you have the controller manager, which is kind of like a watchdog, always making sure everything is running exactly the way you told it to.
And now for the worker nodes. These are the actual machines, the muscle, where your applications get to live and breathe. Each one of these nodes has a kubelet, which is a little agent that's constantly chatting with the brain, the control plane. It's also got a kube proxy for sorting out all the networking rules, and of course, a container runtime. You've probably heard of Docker or containerd, which is the engine that physically runs your container.
All right, we've seen the pieces of the puzzle. Now for the really fun part. Let's actually trace the journey of a single command and watch how all these different components work together in this, well, it's kind of like a beautifully coordinated dance to get your application up and running.
But wait, before we do that, there's one really important word you need to know: pod. A pod is the smallest, most fundamental thing you can deploy in Kubernetes. The easiest way to think about it is just as a little wrapper, a little box that holds the containers where your application code actually lives.
Okay, so you're at your terminal and you type kubectl apply. What happens next? Well, first, your command flies over and hits the API server, that front door we talked about. It checks your request, makes sure it looks good, and then saves it in etcd, the cluster's memory. Immediately, the scheduler sees this new homeless pod and finds the perfect worker node for it. And finally, the kubelet on that chosen node gets the message and tells the container runtime to pull down your app's image and fire it up. And just like that, boom, your app is running.
So why do we even care about this internal flow? Is it just for fun? No way. It's because things will eventually go wrong. As you can see from this real-world story, when a pod gets stuck in a pending state, for example, knowing this flow, knowing which component does what, is the key to figuring out the problem and fixing it fast.
Great, our application is running inside a pod. That's a huge step, but now we have a brand new problem. How do other parts of our system, or even users on the internet, reliably talk to it? Because see, pods are designed to be temporary, and that creates a pretty big communication challenge.
And here is the absolute core of that challenge. Every single time a pod restarts, and it will restart, it gets a brand new IP address. So you can imagine if you try to connect to a specific pod by its IP, that connection is going to shatter the second that pod gets rescheduled. This is a massive problem in a dynamic system like this.
So let me be super clear about this. You should never, ever, ever hard code a pod's IP address. It is a recipe for disaster. Luckily, Kubernetes gives us a much, much better way to handle this, using a stable DNS name that's provided by an object called a service.
I absolutely love this analogy. It just makes so much sense. Trying to use a pod's IP is like sending a letter to someone's hotel room, right? As soon as they check out, that letter is going nowhere. It's totally unreliable. But using a service, that's like sending mail to their permanent home address. The people inside might change, but the address itself is stable. Your mail is always going to get there.
And that's exactly what a service is. It's an abstraction, a stable front that gives a whole group of pods a single, reliable network identity. It gets one fixed IP address and one DNS name that never, ever changes. It just acts as a dependable entry point and automatically routes traffic to whichever healthy pod is ready to take it. Okay, so we've got our app running in a pod, and we have a stable way to talk to it using a service. Now, let's zoom out a bit. How does Kubernetes help us manage whole groups of these pods, handle application updates, and make sure our app is always up and running?
Well, the magic here actually starts with something incredibly simple: labels. Labels are just key value pairs, basically digital sticky notes that you can attach to any object in Kubernetes. So for example, you could label all your web server pods with app:frontend. This is how we start to organize everything.
So we have these labels, these sticky notes. Now how do we use them? With selectors. A selector is just a query that says, hey, find me all the things with this specific label. So our service can use a selector to find every pod with the label app:frontend and just automatically start sending traffic to all of them.
And this is where it all comes together with an object called a deployment. A deployment is like a tireless manager. It uses a selector to constantly watch over pods that have a certain label. Its job is to make sure the right number of pods are always running. If one crashes, it starts a new one. It can also manage updates for you, rolling out a new version of your app with absolutely zero downtime. It's pretty amazing.
Wow, we have covered a ton of ground, haven't we? From the basic cluster architecture all the way to running and connecting our app. So to wrap things up, let's just take a quick peek at a couple more essential ideas you're definitely going to run into as you continue your Kubernetes journey.
First up, health checks. There are two main types. A liveness probe asks a very simple question: is this container alive and well? If it doesn't get a good answer, Kubernetes just restarts it. A readiness probe asks a different question: are you ready to handle traffic right now? If the answer is no, Kubernetes will stop sending it new requests until it's ready. They work together to keep your application super healthy.
And finally, how do you get people from the outside world to your app? A load balancer service is the simple way to go. It gives a single service its own public IP. It's easy, but it can get pricey if you have a lot of services. The smarter, more cost-effective option is usually an ingress. It's like a smart traffic cop that can manage access to many different services all through one single public IP address. Super flexible.
So there you have it. We've gone from the basic architecture of the control plane and worker nodes to running an app in a pod, giving it a stable address with a service, and managing it all with the deployment. We've seen how all these core pieces fit together to build this incredibly powerful system. So now that you see how it all connects, the real question is, what problem could Kubernetes solve for you?